Hello, my name is Goran Mekic, and you're watching the CBSDng podcast on, the CBSDng development. Uh, Today's topic is going to be um, security concerns, techniques, different libraries that can be used, although they are not in in this project, at least not in this stage. But I'm gonna cover some um, techniques that you should have in mind from the start uh, to be able to choose which path to go in development. And one thing that is uh, that is universally true is that you want simplicity in order to have achievable security. So we have, as human beings, the way we think is divide and conquer. That's one of the main drivers behind, uh, for example, inter-process communication and privilege separation. So we want to divide a complex problem into smaller ones. Usually, uh, that's the idea with the model that is architecturally, security-wise sane. So let's start with what we have here. What are the key players in what's the software that we are using depending on, and why use it like that or whatever. So we see it in terminal, proxy, front end, back end, and CBSDng. Those are basically the important repositories. Front end and back end are for the um, web. Terminal is basically a DevOps thing which has proxy and CBSDng as submodules, which Rega knows how to handle. And it's basically a big deal because there are few of them. No, you can't see anything. So, like this. There are quite a few of the um, workers here of the processes, and they communicate somehow, and you need to make it secure. Um, so, the part we're going to investigate first is we're going to start the proxy, and maybe I didn't build. I did. Beautiful. Okay, so we're going to go. All right. Yeah, this shouldn't be here, but trust me, I know what I'm doing. There's a problem I'm gonna talk about a little bit later, um, and this is part of the debugging. So yeah, I know this shouldn't be here, so I'm just gonna play dumb and ignore it. Um, we're gonna see what happens when this is typed. So let's start with. All right. So yeah, this should be a terminal, not a daemon anymore. But yeah. Um, let's just say we don't know how the proxy works. Um, we're just interested in how the two processes, on one end the shell and on the other the proxy, are talking to each other. Um, and then I'm gonna tell you why that's important. But for now, let's go through why this is, um, what's going on in here. So we know we are talking to um, we as a shell are going to talk to the keyboard. I mean, we're going to listen for the keyboard, and we're going to listen and connect to a socket. So for for the sake of this whole implementation of the shell, we know. I think this is better overview. I mean, it's a main, so yeah. So there are two cases. Either I typed the CBSDng as H only, or I gave it some arguments. If I didn't give it any arguments, then act like a shell, right? Actually run the shell with this parser and a socket. And I know I'm not going to, for example, spawn any processes or open any files. No, no, this stage. So I kind of can limit this function more, and uh, there's a potential for restricting these executions even more. But let's just stay on the, um, how to say, the technological side. The uh, huh, damn it! It says I don't have enough streaming power, and I've never had faster internet in my life. Yeah. So, hmm, anyway, there are two modes in which this shell operates. Either it's going to read the, um, line by line from the user and treat them as arguments, parse them with this parser, and send them to the proxy via this socket. Or we gave it some arguments and we need to parse them and eventually send them out, but wait for the output, wait and parse it. I mean, this does the parsing automatically. This is error. This is okay. We're done, and this is okay. Something weird happened. Uh, no, actually, this is uh, when from here I want to inform here someone via message type that the connection actually closed. Uh, this is never sent through the Unix socket, but I need different parts of code to communicate that the connection has been lost. And they are doing it via messages. And this is the output. This message is the output of socket, of what the CBSD is running, right? Plus some more, obviously, because of the error handling. So, um, this is why this is done like this is the reason is that you can assume that uh, in the future you can say, okay, I will never as a shell execute a process, uh, or I know in advance what um, uh, resources I'm going to need, open them, and then if my implementation is such that all the resources are initialized at the beginning, then uh, technology that's called capsicum in FreeBSD can be used. And that technology gives you, as a programmer, as a developer, ability to uh, say, okay, I know my shell implementation is not supposed to spawn anything, to run any processes. And you can say, okay, that's forbidden. Actually, you basically say that's not allowed because everything is forbidden once you enable that library or um what it's called enter capability mode. Um, so uh, let's say that you need to open a file, but you didn't declare you need to open the file because your problem is um, kind of uh, I don't know. Let's say you're recording something, right? You don't know in advance what files you're going to open. Uh, like a musician composing something, maybe you're going to use some samples, maybe you're going to record and then write to files, and you cannot know in advance uh, what resources you're going to need. And for those purposes, uh, there's a technique called privilege separation, maybe better called principle. Uh, in principle, what you do is create two processes. One is highly restricted, like let's say that it's this shell, and one is a bit loosey, but it doesn't do much. That doesn't have much code. Um, this is me trying to kind of tell you that this is the code you should look at as an example, of course, because if I knew any better way to develop an application, I would. Wouldn't cripple myself. So yeah, I'm kind of gonna tell you to do it my way because I like it, but feel free to rip some of it and use it in your own applications. Uh, like the knowledge of uh, capsicumizing applications. There is FreeBSD journal. It has it really nicely covered and it's free to read, so you should read it. It's a really good um, coverage of this amazing technology. Uh, it's annoying because your program is constantly failing and exiting because you didn't think of some resource that you're going to need. But I think it's worthwhile. Um what I'm trying to tell you in the context of a CBSDng is that privilege separation is done intentionally, like this, via Unix sockets and not implemented as a huge shell. First, it's obviously easier to communicate with web backend that way, and second, yeah, it gives me ability to add um, capsicumized code, uh, so my parts of code are even more secure. Uh, how I see it is that when you have uh, capability mode on, you're like saying that, okay, whatever happens that I didn't allow, just break. Breaking a code, but breaking the process, ending it violently is better than actually having something malicious leaking stuff around, right? So it's a security feature. And I got to the part to separate the privileges. Just didn't get to the part to add the uh, capsicum and what is called Casper helping service. Uh, it's like already some things like querying DNS is already separated into a different process, different library that knows how to communicate via uh, Capsicum, and you kind of use it easier than just using the Capsicum itself. Anyway, I'm not gonna talk about it anymore. Check out the journal; it's really greatly covered with Capsicumizer 9000 in it. Uh, really, there's a program called that to capsicumize already existing applications. So it runs them, it capsicumizes and then runs them, and then those rules apply to them too. So no code needs to be changed. Really powerful uh, technology from security perspective. And if you're a security developer, really check it out. On OpenBSD, there's a pledge and unveil, and I don't know any other technologies that are like that. Not that there are not many other. It's just that I didn't research because I know Casper come with a generic FreeBSD kernel, so I didn't need to look any further. Um, so that is one technique and one possible uh, reason for you to um, consider writing code in such a way that uh, it can be uh, put into little pieces, uh, loosely coupled little pieces that you can examine individually or as a group. And it's a it's a way for us human to make us to make a code that is easier for us to read, to digest, right? um, there is the topic is really cool, and it takes a lot of hours to cover it all. But if you're already having thoughts about um, privilege separation, then those processes that are now separated need to talk to each other somehow. And Unix socket is just one way. The network sockets are obviously one way too. And implementation, not implementation wise, API wise for us developers, the Unix socket and iNet socket, which is like internet socket, uh, are not that different. They're kind of declared differently, but not that different to use at all. Uh, Read, write, send, receive, and so on. So one of the cool ways to do it is it would be kind of cool when you could use memory as the fastest um, silicon that is shared between, let's say, cores or between two processes, uh, and their techniques and technologies called memory mapped files. Their shared memory, if you ever saw that SHM whatever, that's shared memory, and that's how programs and applications talk to each other. Um, One way pipes are also viable. Um, Pipes are what is used for example, in the proxy. It has to be an execute. All right, so we can see that the proxy is forking a child and it needs to capture its output somehow. Uh, Luckily, the that is kind of easily achieved on the child process. There's nothing special. You literally just oh, this is wrong. Oh no, no, it's not. You literally just write to the buffer. I mean to the terminal, just like you would normally, because you know you actually don't know, but you don't care that your inputs and outputs are not keyboard and terminal; they are something else. But in a parent, you can say, okay, so the child has something for me, and that's uh, that's how we know that child has some output and how we redirect input. So these are all the techniques. Well, not all of them, but uh, some of techniques that are included in FreeBSD. at least. And many of the technologies are uh, portable enough that they work on almost all operating systems, like shared memory. So, when you talk about security, you're mostly talking about interprocess communication. And if you look around the internet, you're going to see that you have some IPC, or interprocess communication, uh, books and articles, and it's huge. Why it's huge? Because it's a security matter. In how to say security feature of operating system is, and developer, right, working on those applications, is how to make the uh, communication secure between two processes on a same machine, different machines, and whatnot. So one particular problem is human typing naturally. That's why. Okay, let's start with a really simple one. That's why we have the parser, and that's where it all actually starts with what does the user want, and is it secure? What did he type? Did he type something that is potentially harmful or not? So there are two levels, two places where uh, parsing is happening. One is in the shell and one is in the proxy, of course. So let's go over shell parser first. Um, it's going to have, actually, this is what you should look at first. These are all the uh, all the data that is going to be collected from what the user has typed. Uh, and that is not when you log in into a jail, or when the CBSD is asking you questions. This is when you type in the command with the arguments, parse the arguments. What did the user send along with the execution of the shell? Uh, and we know it can use some options. It can use some jails. There's definitely going to be a socket involved, and sometimes the argument is going to be a single jail, not a list of jails. And I mean, sometimes what I mean by that is that this is what all the uh, commands use. All like there's thousands of them. There's four: start, stop, login, and ls. Right, list the instances. And what I'm trying to say is that variables, or the fields that are protected in this parser, what is what actually the parser is going to produce. It's going to take the raw input as a huge string, I mean, huge, whatever the user typed in. And then it's going to break it down into these variables, which are uh, easier to work with as a developer. And there's uh, some access methods for those variables, for those fields. Um, the implementation is actually quite wonderful. This is all the magic. So the first line is all the magic. The library is called CLI 11, as in C++ and 11 uh, library for parsing. Uh, Actually, no, no, it's not. I'm lying. uh, what does the parser do? Oh yeah, yeah. This is what changed. Okay. Uh, CLI is parsing is a parser actually. So one of the things is this is the default path for the parser to use in a socket, and this is all we need to do to make few subcommands like CBSDng, sh, ls, start, stop, and this is here. So we have help. Uh, I have construct. I didn't know how I implemented this. Beautiful. So this is login ls. Right. So let me do it like this. These are the options to the shell itself, like help all and which socket to use, right? Which socket path to use. And there are a few. This is what I want. I'm not sure about this. Is it implemented properly? But anyway, I know these four are uh, login, right? These four work perfectly, and this is the magic. You add subcommand, so you say, I'm going to have a start subcommand. And that subcommand is going to have an option, and you give it any variable, almost any type of variable, and you say it's either required or not. And there's some description. What any type of variable means is jails is array. It's a vector of strings, right? This is what jail says. While jail is a single string, and there is just a subcommand. There is subcommand with the option that is array, like when you say start one jail, second jail, 15th jail in a row, right? You just pile them up and it's gonna start them all. Or when you say a login, the argument has to be a single jail. It cannot be two, right? And uh, because this is a string, the CLI 11 knows that adding option with just a string will, will have to be just a single value, and you don't have to take care of that. So it's also either required or not. Uh, I don't have optional arguments here or options. Yeah, but right, if option starts with an S, sorry, not with an S, with a dash, uh, it's what we as users who are typing in commands are calling options. Otherwise, it's an argument, what we would call an argument. but it's implemented through the same function. It's really, really cool. And it has a long option parser and so on. Uh, why I'm telling you this, security wise, uh, it's really hard to properly parse whatever the user is typing. One of the hardest problems in computing, security wise, is are you sure we should do this? I mean, a puny human told us that this should be executed. Should we trust him? Right? And that's the hardest part. Uh, how do we know that the given arguments are not going to create some problem, memory leak, uh, information leak, or whatever? So yeah, the parsing is a huge chapter in security. I think it's foundation for any security based system, and that's why I'm maybe boring you with these details of how to actually get the data out of a human. But yeah, that's not an easy task for a computer. That's not an easy task. Luckily, this is all I need to do. When I create a parser, it's going to say, okay, give me, sorry, create a structure. Tell me how do you want me to parse the string that is incoming. And these are the rules. This is how I want you to behave. If there's a start, I want you to require at least one jail, but multiple are allowed. And you can imagine if you parse this by hand, that this is going to take forever, first. Second, your eyes are the only ones that have been staring at the problem. That's that's not many people who validated that it works. And right, we don't like single point of failure. Uh, so the idea is to have perfect parsing and perfectly separated problems that you're trying to solve so that implementation is simpler. Um, I think that's enough of the dry talk. That's really not the fun topic, especially when it breaks your program and you need to rethink how the structure, the workflow. Uh, so yeah, it's not something that can be applied in the end, but you can gradually get to secure product by thinking in advance about the principles like inter-process communication. How or if you do privilege separation, how your uh, separated processes are going to communicate, and is that channel secure? Do you need to encrypt it? Does uh, is it remotely connectable or not? Right. So if you have all those considerations in advance, then you can leave out something to implement at some later time in the future, like For example, I do plan to add Capsicum and Casper, probably Casper. I didn't check which services it provides. I mean, I don't know the whole list, but I know it's an overkill right now. But I know what it requires. It requires that you basically declare what you need at the beginning of the program. So it's all about planning, and you can do it later only if you plan it from the beginning. You cannot leave thinking for later. That's a security paint. That's what a friend of mine calls a security paint. Like afterthought, security cannot be an afterthought. It has to be embedded in your development from the day one. Uh, I would say day zero, but day zero is idea. But yeah, from the day one, you have to think about security and structures and like a workflow that you're going to have to follow because you plan to add some security features or principles. So, yeah, one day, I guess we all say that, but one day my program is going to be perfect. Um, that would be all for today. So, oh yeah, I promised you a failure, and the failure is that the shell doesn't actually work. I mean, it does. All right. So just run this command in a loop. You can see this, right? And what happens is that there's an error sometimes. Uh, these bugs are the hardest to find and track, and I'm afraid I'm going to need maybe even a few weeks, if not months, to track this one down until I say, okay, now it's safe enough. So you can see in a lower. Okay, let me show it to you like this. See where the one is? That's where the proxy is, and that's where the problem is. I don't know why sometimes it dies. I examined the core that it dumps, and there's just some problem with a thread and a destructor. So uh, we're going to make a pause so I can properly debug this problem before we start streaming about the new stuff in CBSDng. I hope it's gonna be for a while. I would like to wake up in the morning and realize where is the mistake I've made. But yeah, until then, we're going to make a little pause and to give me some time to actually deal with the problem. So you can see it's not so often that I can cause this error to occur, which is extremely annoying. How do you catch something like that, right? And yeah, I bet it's gonna be a hell of a story. So yeah, until I uh, fix the the shell, I think it's actually the proxy. Uh, but anyway, the proxy shouldn't die like this. So until I fix it, I have to say that we're not going to stream anymore. We're continue streaming as soon as my program starts working. Until then, thank you for watching, and I hope it was educational. And take care. Bye bye.